This is a review to help guide some of your studying and refresh your memory on Riparian ecology and management. Oh, I don't know how to make it move forward. Okay. So just as a reminder, when we're referring to riparian ecosystems, those are the ecotone, or the ecosystem in that area that sort of, there's a dynamic between the aquatic environment and the terrestrial ecosystem. And so it's often characterized by unique soils and plants. This is a way that if you were in the field and you were asked, you have to outline the riparian zone of, say, adjacent to a wetland, you would use soils and plants as indicators to try and delineate that riparian zone. In the riparian zone, the reason why it's so important and unique is that there's a number of different processes, species, dynamics that are very unique to those zones relative to the aquatic ecosystem and also the terrestrial ecosystem. And of course, we've talked about how there's all sorts of unique sort of dynamics and processes in the riparian ecosystem. So being familiar with what some of these are and why they're important will be important for your midterm. And so again, there are zones where there's a lot of sediment inputs and deposition. There's unique microclimates, as well as the importance of bank stability from large wood or plants that are rooted along the banks. Importance of litter and wood for the whole aquatic ecosystem is also significant. Invertebrates and litter drop and coming from the canopy, as well as providing unique habitat for certain species. Lastly, this whole dynamic of nutrients that are coming from below the ground, although we haven't talked about that very much in this class, just recognize that that's another sort of, from a biochemical nutrient dynamic perspective, is happening in a riparian ecosystem. So there's a number of different key attributes to riparian areas. We talked about different microclimate parameters from a biodiversity perspective. We talked a little bit about the below ground hyperheric dynamics, as well as some dynamics with large woody debris. And so just as a reminder, this graphic here was a good illustration of the influence that trees will have from a shading, coarse wood, or root sort of strength, stability, or litter fall perspective, and how that importance of these different attributes will change depending on the distance from the channel. So for instance, root strength, only about half a tree height length from the edge of the bank will be where that sort of maximum influence of those trees or the plants would be. So further than that, and it's not really an important contributor. From a species richness and diversity perspective, I talked about this during the Kahoot, but there's this question as to whether or not riparian zones are areas that have the greatest amount of species richness or the greatest amount of species and diversity. Is this actually true, has been a question. There have been some studies that have demonstrated that yes, in fact, this is true. And some of the reasons for that have to do with this high frequency of disturbances, so lots of flooding, channel migration, wind throw, but also that there's because it's so dynamic, there's going to be a lot of little different unique little pockets or microsites where you're going to have unique attributes or habitat features that would be conducive to the habitat needs of a certain species. It's also possibly linked to the high productivity. And so that is another sort of aspect of why riparian zones are so important. So this was a graphic that we talked about in class, and one of the studies that supports this idea that yes, in fact, species richness and species diversity is greatest in those riparian ecosystems. And so here in this graphic here, the little dashed line is hill slope, so that would be like upland environments, and then the other line is the riparian environment. And on the y-axis here, or the vertical axis, indicates the number of species. In other words, look at that. There was quite a bit more, almost double the amount of species in the riparian ecosystem than in the upland forest, regardless of the age of the forest. So even up to from about 5 years to 500 years, you always had more species. From a species diversity perspective, diversity is a different metric. It's like, in this case, they're using what's called the Shannon-Weiner index. It's a different measure. It includes richness, but it also includes sort of the proportional abundance of that species in the environment. And that trend was quite consistent, was that generally riparian ecosystems had more species diversity than the upland hill slope. And we went over this table again, but this is another reason why those riparian environments are so critical, is because there's a whole suite of species in the Pacific coastal ecoregion, so that's in our region here, that depend entirely on those unique habitats. From a productivity perspective, what we're talking about is water, nutrients, the type of light regime. Essentially what we're referring to is that those, I think I didn't want to include this slide, but I did. Here we are, is that, that those riparian ecosystems, not only are the areas that are like, have a really high soil moisture regime or nutrient regime, but they're also productive in that they have lots of inputs into the aquatic environment. So leaves and needles and wood, all these things help to contribute to the productivity of the stream itself. So here we did this in class, was we went over how some of the more key site series would be these sort of like high productivity areas where you have high soil nutrient regime and high moisture regime. And those areas tend to correspond with, look at even in here, a significant amount of indicator species and a lot more, a greater species richness than you would find in other site series or ecosystem types. We talked about this being significant, so just a reminder again that these areas, these zones are also this dynamic between the above ground, stream water moving in below ground and below ground moving above ground, and that that is also happening below the riparian ecosystem as well. So it's not just the stream where this dynamic is happening, but below the terrestrial ecosystem, the riparian ecosystem. And we talked about in the Kahoot how the drainage basin also, that there's different sort of dynamics that are going to be happening. And if you recall how we talked about different stream morphological types, so the ripple pool, cascade pool, step pool, non-alluvial, those streams and their location in the watershed are going to be strongly driven by some of the geomorphology sort of dynamics, disturbance dynamics, like the fluvial processes or more mass movement processes, but also gradient is a big driver. And I showed this in the Kahoot again, as here is an example of the sediment movement and the outcomes of that sediment movement, and the starting with a landslide up in graphic A, and then how that sediment will move through the watershed. There's a real important relationship among the large wood inputs and the riparian ecosystems, but also the stream processes. And so we talked about that. Here's an example of, see, all these trees have all come down right along the edge of the channel. And what that wood can start to do is build different log jams or debris jams and larger streams, and those can start to contribute to the formation of new sort of channel bars or islands. And so you have the beginning of sediment deposition being captured around this log, for instance, and how over time more logs will sort of and debris will sort of jam up against that log, and you'll start to get the formation of new channel bars. And how now suddenly you have this little back channel, And all these little nooks in the channel and in the stream are super important. So having this, unlike, you know, Gishon Creek on campus, which is like this very, it just has no sinuosity. It's going to lack the kind of habitat features that are critical for fish. And so this is an example of how significant large wood can be in a channel for the creation of these different channel bars and islands. And like we talked about is that riparian ecosystems in the small little headwater streams, that those are actually really important streams. And currently, there's little protection of these streams when it comes to riparian management. If you recall, this would be like an S6 stream, which will have very little buffer on it. And there's reasons for that. From an operational perspective, it would be very unfeasible to put buffers on everything, and perhaps even more cause more of an impact on the landscape. But there are things we can do to reduce the impact. But what is important to consider is that headwater streams, or these little first order streams, or S6, they may actually, in some watersheds, compose or account for about 80% of the total stream length in many drainages. So what that means is that 80% of our stream length in our watersheds are more susceptible to impacts from forest management. And that's a conversation that is happening across the province right now, is what can we do to reduce that impact? So along a headwater stream, what is also different than perhaps along this like fourth order or third order stream is that the coupling between that stream and the processes that are happening in the riparian ecosystem is very strong. So the stream is very vulnerable or connected with the riparian area, perhaps more so than these larger streams. And this is coming out of, John Richardson is from UBC and is a leading researcher in riparian ecology and management. The last thing I wanted to point out here, and I talked about in that first introduction to this, was that it's important to recognize that riparian ecosystems, they're not static in time. It's very, very dynamic, and that fluvial processes and geomorphic processes are going to create that dynamic. And because there's such a strong link between the terrestrial environment and the aquatic ecosystem, that link in itself is always changing over time as well. And as an example, here's a Chilliwack River valley that you had a chance to travel through. And here are two snapshots in time of the same stretch of the Chilliwack River. And you can see how the main channel is running through here. And now look at that main channel just 7 years later, how different it is. And how this was like a dry sort of channel bed that you can see that this is where the river used to flow, but in 1959 it's flowing there again, and there seems to be a side channel. And again, if we compare 1983 to 1991, again the channel has changed, and therefore the riparian environment has also changed. This is an extreme case. This is a huge river, and it's very, very dynamic. But in the smaller systems, we